Okay, so we on Friday have 6-4 due. Quiz 6-4. And then you're like free for spring break. Is this the last assignment due before spring break for you? Some of you, at least? Okay, well then let's... No, there are other ones. I'm not the meanest teacher. Is that what you're saying? I gotta up my game. That's some rookie numbers here. I gotta... Okay, so let's go over some questions. Request before I just pick some that I want to go over. Again, we'll be repeating some probably, but that's okay. We missed it before, or some piece you thought you had, you didn't have as much. Yeah, I guess. Yeah. Like with rates already, or we have to calculate the rates too? Okay. So total for units completed and transferred out. And here we have these two rates here. Is this a good enough problem or a different problem you're looking for, maybe? Okay. All right, so this problem here is looking for total cost of units completed and transferred out. And it gives us a little different format from other questions, but this is all the information we're going to need for this, I think. Yep, it has to be able to be completed. And I gave you the two rates as well. All right, so let's just for the sake of posterity here, Wikipedia Brown Industries produces gemstones and uses process costing to determine the cost of these gemstones. Firm uses the FIFO method. Firm's polishing department, the firm's only production department, has the following costs per equivalent units. So the reason why I have this little a positive part of the sentence right here is just so you know, there's no transferred in costs. It's not like department to department. This is the only department, so no worries about transferred in costs. And we have these two rates. So we already calculated TEU. We already used TEU. So okay, we already calculated TEU. So should we ever be using TEU? No. The rates were calculated already using TEU. Great. Don't use TEU. Don't let that equation infect any of your later efforts here. Okay, it's easy to slip up. I get it, but make sure you don't. So yeah, all of our cool FIFO calculations are already done to get these two rates. Now we just need to apply them to this period's to the units completed specifically. All right, so we're gonna do something with these numbers right here. What do we do with those? I put them into orbit. Yeah, that's my dumb memory kludge, mnemonic to try to get you to remember. You take those numbers, you put them into orbit because they're going to come back around at the end of the process, but you want to make sure you don't use them just yet. Instead, we need to take this number and do something to it. What do we do with this number right here? It's an arithmetic function. Add, subtract, multiply, divide. We're going to subtract beginning with equivalent units specifically. Yes. So this is our units completed, but some of that work was done last period. So we're not going to use this period's rates for that work done last period. No, of course. Like you just say on your day-to-day to your friends, you're like, well, we're not going to use this period's rates for last period's work. It's a common conversation you'll have over spring break. So take this 2,700 and subtract away direct materials, beginning with equivalent units, which is 100 units times 100%, so 100 equivalent units. And that's now 2,600. We'll get these numbers in this spreadsheet in a second. And take this 2,700 here and subtract away 100 physical units times 40% complete, or 40 equivalent units. So you get 2,660 as our units completed with this period's work, or equivalent units completed with this period's work, that we're going to multiply the rate by with respect to conversion cost. So let's put that into our... I don't know why it asked me again. It's like, are you sure you wanted that? You just put it over there, but you're trying to be too smart. All right, so FIFO total. Oh, it's the wrong screen. FIFO units completed, total cost, problem, rates provided. Okay, we have 200 is our DM rate, 800 our CC rate. We have 2,700 is our units completed. And we said that beginning WIP 100 beginning WIP units times 100%, just number one, is our direct materials beginning WIP equivalent units. Here, I think I more often write it this way. Beginning WIP equivalent units with respect to direct materials. And then 100 times 40%, right here, is our beginning WIP equivalent units with respect to conversion costs. And so now, subtract away. This is our equivalent units with this period, completed with this period work for direct materials, and the same thing for conversion costs right here. Okay, great. Now we can multiply those numbers by our respective rates. So we figured out how much the work we did this period cost us. Oh, there it is. Okay, so that's our DM for work completed this period, for units completed this period. At least with this period's work, how about that? And then conversion cost. Okay, now we sent those into orbit. They're back. We have 24,000 DM beginning WIP costs and 7,500 conversion costs in beginning WIP. Beginning WIP, oh, there we go. And we can sum, now no. Yeah, maybe it was right. All four of those. And you can do some subtotals if you want, but ultimately we're subbing all four of those. DM costs with this period's work plus beginning WIP DM costs, and conversion costs with this period's work plus beginning WIP conversion costs. That should be our answer right there. Does that look okay, Jesse? Yep. Okay. All right. Total cost now. Total cost of units completed and transferred out. Yeah. Mm-hmm. Yeah. So we don't have one that's like that, but it's phrased something like total beginning WIP costs were this amount. I'm just giving you this number right here, that 30. I've just summed those already. So yes. I forget the second part of what you said, but yeah, you just add that total number to these two right here. Yep. Okay. Any requests? I'll do one if you don't have a request, and I think we can finish, move on. But yeah, we can.
So it's any blue auto company one with.
Yes.
And it's similar to what you were saying, where it's just the total work cost there.
Okay.
And this is total cost completed and transferred out.
Okay. Let's try and find something. Let's go searching. We can take 30 seconds to a minute here, a couple minutes, and find it. A question similar, at least. Nope. This is what I get for being not as creative as I could have been with company titles. All right, well, go on. Give me another couple tries at least. Okay, this looks like something like what you described. Got total beginning whip. This one right here, even. Okay, cool. And Paul, you were talking about something similar. Same idea?
Yeah, it's the same thing, but different numbers. Yeah.
Okay. All right, so the question stem here at the bottom is what is total cost of the department's units completed and transferred out for this period? I'll scroll down just so we can see on the video. And we have our two rates. I'll scroll back up. We use FIFO. We're the first production department is what we're looking for, which is great because that means there are no transferred in costs. We're transferring down to other departments, sure. All direct materials are added when units are 50% complete with respect to conversion costs. Well, guess what? That's irrelevant to us potentially. Yeah, maybe it is. Oh, let me step back. We don't have to worry about that in terms of calculating the rate. We'll come back to whether that's relevant for other stuff. But useful note either way. And then here we have our information. Again, formatted slightly differently. Beginning with units, ending with units, units completed. So I didn't bold this, but sometimes I do because sometimes in this slot you might be expecting units started, and you go, oh, I got to fill. I give you units completed right here. All right, so, and then I gave you just total beginning whip costs. I didn't break it out by direct materials and conversion costs. So let's do FIFO, total cost, beginning whip types together. All right, so what we're going to need to do is take our units completed here. Well, we're going to do the same thing as we did the last time. So we have our units completed. We need to subtract away the beginning whip equivalent units. So for conversion costs, we have 75% complete with respect to that type of category, that type of cost, 70%. So this 5,000, let's copy over some information first. This unit's completed. And then we have 5,000. You know, I'll break it out so it's easier to see in case we're looking at it. 5,000 is our beginning whip units, physical units. And they're 0.75% complete with respect to conversion cost. And they are what percent complete with respect to direct materials? 100. I saw somebody say 100. Yeah, because this 75% is past the threshold, which means all direct materials have been added to these 5,000. So 100% direct materials percent complete. All right, we can just take this. Now we have our beginning whip equivalent units with respect to conversion cost, our beginning whip equivalent units with respect to direct materials, and we can subtract those away from our units completed. So this is conversion. This is equivalent units with this period's work for conversion costs. And that is equivalent units with this period's work with respect to direct materials. Then we get to multiply those numbers here. This 146,250 by the conversion cost rate, $75, and this $145,000 by this direct material rate of $50,000. Excuse me, $50. Wow, $50. Here, I'll reorder them here in the spreadsheet so they match what we've been doing. Rather than copying and pasting all my stuff in the spreadsheet, let's just flip these, copy them over, 75 and 50, and multiply. So CC rate of 75 times the equivalent units done with this period's work, equivalent units completed with this period's work with regard to conversion costs, gives us 10 million. And do the same thing here with direct materials, and we get, looks like a 7.25 million. And then we can add in the beginning whip costs, which are a compound of direct materials and conversion costs. Okay, so that, let's see if that's one of the answer choices, first of all. Whew, okay, good. $18,723,750. Good? Yep. Awesome. All right. Sure. Yeah, I was gonna try and do that just to finish this up. Any of these will work. Let's see. I just want to do one. I don't want to do direct materials and conversion costs. Let's do this one right here. All right, FIFO comprehensive. So in 6-4 here, the only way we're going to get without the rates given, we have to calculate the rates, is a comprehensive problem like this. So, all right, let's copy it all over. 24, 6, 27. Should I work on it aside and give you a minute or two? No? Okay, well, I'll work through it here for you. We're just making our T account. Okay, units completed. And I'm just going to copy over the conversion cost information because that's all I care about. The question says, what is the conversion cost for units completed and transferred out? All right, so that's percent complete with respect to conversion cost for beginning WIP and ending WIP right here. Just copied it over. So TEU equals units completed minus beginning WIP equivalent units plus ending WIP equivalent units. So units completed minus beginning WIP equivalent units plus ending WIP equivalent units. That is our TEU with respect to conversion costs. And we're only going to include in the numerator current period. We've set aside our beginning WIP sent in orbit beginning WIP costs, 5316. Current conversion costs, current period conversion costs. That's our numerator. TEU is our denominator. This is our CC rate. Okay, so now when you take this units completed and subtract away the beginning WIP equivalent units. So we can multiply that rate by the equivalent units completed with this period's work. All right. So that is equivalent units, this period's, It's the thing we're going to multiply the rate by under FIFO. So this is conversion cost with this period's rate. And then we need to add back in 570. Now back from orbit is this 570. We should be able to add that. That should be our total conversion cost of units completed and transferred out. Let's double check, make sure I haven't messed something up here. Okay, sound like pretty good? You have to remember steps 1, calculating TEU, in which case you are going to use it. And then step 2 of what do I put in the numerator? It's not too hard. And then you do step 3. Yeah.
This is a pretty good question.
Okay.
So when we just did before this, the company one,
Mm-hmm.
you can do that one like that with ending WIP balance instead of transfer.
Yeah, we haven't done any ending WIP balances here, have we? Sure, we did just 2 questions here. Let's see if we get the points. It's a minute. Search for an ending WIP balance one. Wow. When we were searching before, I kept getting like 5 ending WIP balance ones every every time. Maybe it's not phrased ending WIP balance in all these. I wrote up ending WIP, e-WIP balance. Okay. Fault of my search. There. Let's get back to it. Go away. This one looked pretty good. Okay. So this is going to be fewer steps. You're going to feel like these are vacation questions on the quiz, or you have probably thought these are vacation questions. Because you just take these rates, which is DM cost per equivalent units, CC per equivalent units, and to multiply them by the equivalent units in ending WIP. So we have 800 units times, let's see, they're all added at the beginning of the process. All direct materials are added at the beginning of the process. So times 1. And 800 physical units times 20% with respect to conversion costs. So multiply those rates out. This is our DM in ending WIP, conversion cost in ending WIP. So some of these should be our ending WIP balance. They're good? All right, well, I'm going to go ahead and submit it. And let's go ahead and start talking about Chapter 7 stuff. So after spring break, we will talk about variance analysis, and in some part, it's going to be a review. I took this picture myself. I'm pretty proud of it. It's like going to go in my obituary as a life achievement. Yep. That's what I do, misunderstand fast food signs on purpose. I know what they mean. Whoever comes before me likes to hide away all the erasers from the middle. Oh, yeah, because he has that screen up, he or she has that screen up, and uses the erasers over there. All right, well, variance analysis. This is where I get to talk about what I like to do as on the other half. There are 3 halves to your work as a professor. The first half is teaching, the second half is research, the third half is service, where you work on the committees, where you create bylaws and go to sleep because you're tired. Saying it's I don't want to get into too much about that, but here I get to talk about the research part. Saying it would be boring to you because it's boring to me. A research part is exciting to me. Maybe not to you, but there's some overlap right here in this chapter, because to be a good variance analyst in a company, or to do the variance analysis well, to get the problems right in the quizzes, you have to have, at least to a degree, you have to be, to a degree, a good scientist. All right, so when you're a scientist and you're doing an experiment, you're trying to find some causality. This cause leads to this effect. That's why I did the experiment. And the critical thing you want is experimental control. So what you don't want to do is you don't want to say, well, I was teaching this one class and they really got the material. And then I was teaching the other class and they did not get the material. And the first class that got the material, is that how I said it? First class got the material, second class didn't. Well, I need to know what the difference is between these classes. I don't want to just say, well, one got it and one didn't, so the one characteristic about this class must be the cause of that. What if I give you this example of those 2 classes? I teach one class, which is, let's say I teach an intro class at this college right here, and they got the material really well. And then I teach a different class at, say, 314 level, but at a very different university about 5 or 10 years later, and they did not get the material very well. It's going to be very difficult for me to say why the difference. Kind of struggling with my words today. I don't know what it is, but so what is all the difference between these two classes? One was 206, one was 314, or through the similar levels. One was at one university, one was at the other. There was a time gap between them. So I'm a different teacher. They might be different students in time. So any one of those could easily be the reason why there's a difference in how well people get a particular material in this example. Let's talk about a different example. You're trying to, let me stop with the examples here. It's because of those three things going at once that it's a problem. I can't drill down to causality. So we've got the good class. Let's make it the good class, the 314 class. Okay, good class. And they have a variety of characteristics. They're in 2024, and they're at the 314 level. They're full of awesome students who have never rated lower than 5 stars. Okay, there's that joke back again. This is a joke, please. It's just a joke. And I don't know what else do you want to say about yourselves? You meet in the afternoons. We're not on lockdown. And you compare that to the bad class. Oh boy, which is not you. Bad class, didn't get it. Okay, well, this was in 2020. This was 206. They were not awesome. Always rating their professors lower than a 5. Oh my goodness. It was at 7:30 in the morning. And also it changed to online halfway through. All right, so if I'm saying trying to improve my teaching, and I'm like, well, they didn't get it, they did, what should I do to improve? Can I tell what I need to do to improve just based on these 2 data points? Somebody shook your head, Heather? Yeah, I would agree. As a scientist, I say to myself, well, look, it could be this, 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 it could be this interacting with this and creating a new effect altogether. There are at least, six dashes there. They're saying 5 dashes there, 5 different characteristics that differ. And each one could be interacting as well. So we could get to 10, 15 different reasons why these two might have differed in their educational outcomes right away. What you want to do if you're doing a science experiment is you want there to be one difference between the 2 things you're comparing. And then you can say, well, good outcome, bad outcome had to have been from this one difference. It was the only thing that differed. Everything else was kept the same. I have experimental control over this. So if instead, for example, I say, let's stop making it good and bad. Let's say good. No, I don't want to do that because I want to talk about. The only class I'm teaching right now is online, so I'm like, I got to compare here in the online. It doesn't matter. Even that doesn't work. Even that makes it tricky because we have the in-person class. If I'm comparing outcomes from the in-person class and the online class, it's no longer good and bad. I'm not making fun of anybody here. Yes, the online class is online. I have to change the curriculum a little bit there, how we do attendance and whatnot. So they have these discussion boards that they get involved in. There's also the fact that certain people are going to choose the online class. If I've been there. My master's was entirely online. I was working at the time. If you're working, the percentage of people working in the in-person class and the hours you're working is lower on average than the percentage of people who are working and the hours that they're working online. So that's another thing that differs. Even though I'm teaching the same class 314, the same period, and I'm with the same lecture videos, there are still multiple differences that could explain a difference between the 2 classes. All right, so the whole idea of variance analysis in theory here is you want to get it down to one difference between the 3 things. And really what we're talking about is we're going to spend 99% of our time talking about the difference in costs. Name of the class is Cost Accounting in Chapter 1. We kind of breezed over it. Whole idea is we're going to spend a lot of time figuring out how to maximize profits by figuring out what is driving these two, revenue function and cost function. And we can have more control, and perhaps we often have more control, and it can take a little more definition to figure out what's in the cost function and we spend our time on that primarily, or at least proportionally higher as a result. So hence the name cost accounting, almost synonymous with managerial accounting. At least we're treating it as synonymous in the class. So anyway, we're trying to say why to the cost level. Okay, well, we need to drill down to one difference between two numbers. And that's how we're going to figure this out. We're saying here is the actual cost of some category of cost, and here was our expectation, our expected cost. There's a difference. Maybe it's a good difference. Maybe we spent a lot less than we were expecting. Well, why? Wouldn't you like to spend a lot less, a lot more times? It sounds kind of weird, but wouldn't you like that kind of surprise more often in your life or in your company's life? Yeah, let's kind of try and repeat that. Why did we have this good surprise? Maybe it was a bad surprise. Maybe we expected to spend a certain amount, but we spent a whole lot more than that. Ooh, we should probably figure out why, so we don't have to repeat that in the future. Now, well, how can we drill down to why if we don't have a single lever, as often what I say, a single lever we're pulling between these two? And here is the problem. There are multiple levels going into determining the cost of something. So we're specifically talking about our three categories of cost, product costs: direct materials, direct labor, and overhead. So why was direct materials higher than budgeted or higher than expected? Why was direct labor lower than expected or lower than budgeted? Why was overhead the way it was? Well, let's start down that rabbit hole a little bit. So variance is the difference between budgeted results and actual results, and variance analysis is the comparison of those two in such a way that suggests a specific action. When we ask why, we're asking why because we want to take an action to either get more good results or get fewer bad results. More positive variances, fewer negative variances, or more favorable versus unfavorable is really the word we use. All right. Let's just zoom down a little bit here. Yeah, I even talk about, look, we're doing something quasi-scientific at least. Look, it's not going to be, you don't go into your business and you write up a research paper, but you can pull some of the ideas so you can do this job better when you're doing variance analysis. Pull some of the same ideas along. And it suggests action. At the very least, when you drill down to, when you do variance analysis well, you know the right person to ask the right questions. And then you can formulate an action based off of that so that you can improve profitability in the future. So let's give an example. Let's go down. Let's go down to our mountain range. Not that, past that one. You know what? Let's go this one. That's fine. All right, so here's where I'm going to introduce a mountain range we could use, but then we're going to create a problem with it. And we're going to have to expand the mountain range. All right, so we have, well, I'll just point to the board. We have actuals, our actual cost. So direct material and direct labor says, fine, let's just pick one. Let's say our actual wages we spent as a company, our actual direct labor cost is based on the actual quantity of hours that they worked times the actual price of their labor, the direct laborers. That sounds reasonable enough, right? Yeah, that's how paycheck works. Thanks, professor. Okay, it's really dumb. I get it. But that's what actually happened. When we formed the budget, like last year, you form an annual budget, you're usually finishing it up by September, October timeframe at latest, and then it's for the whole next year. So if we're in December, we might have formulated the budget 14 months ago. But it was based on, well, we think we're going to use this quantity of direct labor hours times this price per hour that we expect our direct laborers to charge for their time. Okay, well, there are two pieces that go into this expectation and two pieces that go to two drivers that go into this actual. And so we can pull out two different levers that might be affecting our our variance here. The difference between what actually happened and what we expected to happen. They are the volume of hours and the price of those hours, right? So we're holding price constant between these two, and the only lever we're pulling is the quantity. So we're comparing directly these two right here. And so what comes out has to be driven by the difference in quantity here. And here we're holding quantity constant. They're both on actual quantity terms. And we're varying the price. So what I don't have here is multiplication. I don't have an X to signify multiplication, but that's what's happening. Actual quantity times actual price. Actual quantity times budgeted price. Actual quantity times, or budgeted quantity, times budgeted price. And that creates that number there. And then what's happening at these mountain ranges is subtraction. So actual number minus the flexible budget gives us price variance. Flexible budget minus budget, static budget we're going to call it, gives us volume variance. All right, now that sounds good, and I presented it nicely like it's the right thing, but it's actually a little wrong. Here's the problem. What do we mean by quantity? Specifically budgeted quantity. Budgeted quantity. Because like I said, I made a real point to emphasize that this budget might have been made 14 months ago, a long time ago. Did you know much about your life right now 14 months ago? And you're not even like a giant company. You're just one person. You should know yourself pretty well, shouldn't you? Okay, well, as a company, you definitely got that number wrong. I mean, the companies never get it right. It's like winning the lottery to get your static budget number to be exactly what you expect or what actually happens. There are lots of things that happen over the course of a year or over the course of months. So that static budget number is probably wrong. Specifically, the quantity was wrong. All right, so here's how we formulate it. Back in September, we said, we think we're going to create 1,000 finished goods units. And it takes our workers 2 hours to complete a finished goods unit, which means we're expecting 2,000 direct labor hours. That logic is pretty sound, right? That's fine. Well, we now have 2 drivers that are potentially there. So when we directly compare actual quantity to budgeted quantity here, we don't know which of these is driving it. Is it because we produced more finished goods units than we were expecting, or because we took longer than 2 hours per finished goods unit? We've got to disentangle those further. So really we get down to the full mountain range is this right here. All right, so here is where we can pull out those 2 potential drivers of budgeted quantity. All the way far on the right is the static budget, the most hypothetical and fictitious of all the numbers on here. And as you move to the left, you're getting more and more into reality. You're incorporating more and more of reality into it. So the first move you do is you take static budget, which is based on the static volume of finished goods units you're expecting to produce and sell. And you say, all right, let's compare that to the budgeted quantity if we had the actual finished goods units. So let's say we actually produced 1,500 finished goods units. This is our actual. This was our budgeted. And if back in September, last September, we knew, let's say, for example, here's my dumb example. Let's say you build a time machine, and instead of just doing something cool with it, you say, I'm going to go back and I'm going to tell myself when I was budgeting direct labor hours exactly how many finished goods units we're going to produce. Just because I'm a nerd. So you build a time machine, you go back, you go into the room where they're doing the budget, cause several heart attacks, and you say, hey, we're going to produce 1,500 units, not 1,000. Okay. Well, once you've left, people have recovered. Now, the flexible budget, they would have budgeted 3,000 direct labor hours based on actual volume. We're still using this budgeted expectation of how much direct labor time it takes per finished goods unit. But we're using the actual volume. So the difference between those two has to be down to how much volume we had. I don't think I have many or maybe any questions that directly ask you for the volume variance. It's just not as useful from a cost management perspective. In part because, does this sound like a good problem to have? Oh, we actually produced 50% more than we were expecting. Sounds like demand was high. Sounds like we had a Chewbacca mask problem. Remember that a few years ago? Was that 9 years ago? Oh, don't tell me that. It's 2015. Yeah. We had a run on supply, so we started producing more. That sounds like a good problem to have. But look what happened. We increased the direct labor hours we were expecting by 3,000 hours based on that. So it sounds like it's actually going to be an unfavorable variance because we produced extra. If you're able to interpret it, you can use volume variance to your advantage. We're going to focus on these two over here. The key, though, is there are going to be questions that tempt you with information from the static budget. Yeah, that's me being mean. You're going to be tempted to use this information. You have to be strong and use this information. The actual volume times the budgeted quantity of input per volume. Actual volume times budgeted quantity of input per volume, per unit of volume. This is the real struggle we have. The real struggle that a number of you will trip over at least once in the question. What are the units we're talking about? We have units that are finished goods units, and I'll use the word volume for that. And we have units which are input units. That's units of DM, units of direct labor, units of whatever the driver is for predetermined overhead or for overhead. And so units is used in both of those terms, and we're translating between the two. All right. We bring from fiction to reality our volume with this move. And now we're going to say, okay, well, let's go ahead and compare budgeted quantity at the actual volume we would have expected. Given how many finished goods units we produced, we would have expected this amount of direct labor cost. Our budgeted quantity of 3,000 direct labor hours times whatever the price is. Let's make it nice and easy, and let's call it $10 per hour. Nice, easy 30,000. Nice, easy 20,000. And now, so that was our volume variance, right? So 10K was our volume variance. Now we're going to start with this 30,000 right here. Well, once we had the time machine come tell us we were actually going to produce 1,500 finished goods units, we would have budgeted $30,000 for our direct labor cost. Okay, now hold that price of $10 per hour constant and figure out how many actual labor hours we used. So we would have budgeted 3,000, and let's say we used 3,200 direct labor hours. It's our actual quantity of direct labor hours. Times 10, 32,000. Now, I've never been satisfied with the term used in textbooks for this. Some of them just leave it untermed. I call this the quasi-budget in the book here. It's actual quantity at budgeted price. So we have actual quantity of direct labor hours, and we're saying quantity here. We're specifically talking about input units, quantity of input units. And the budgeted price, which is $10. So 32,000 at quasi-budget versus 30,000 at the flexible budget. What's the variance? The difference. 2,000. Yeah, thank you. It's really easy. Don't overthink it. $2,000 is the difference. Okay, so we were 30,000 here. We moved to 32,000 here. That's a $2,000 difference. That's the quantity variance. Because we used 200 extra hours. We were expecting 3,000. We used 200 more than that. At $10 an hour is a $2,000 variance. So we call them, just to remind you, we call them favorable or unfavorable. If the cost, because we're going to be doing 99% of our analysis on cost issues, if the cost went up as we moved closer to reality, that's unfavorable. You can always do that logical test. Make sure you're not going crazy here. Also, if you line up the subtraction like this, so this minus this gives you price variance, and this minus this gives you quantity variance, and this minus this gives you volume variance. We have 32,000 minus 30,000. We have a positive 2,000. Positive numbers are unfavorable. If you want to learn the sine rule, that's fine. I like to think about, well, am I getting closer to reality? What's the lever I pulled? Was the actual higher than the budgeted? That's not favorable because it's a cost. I like to usually leave myself breadcrumbs and think through it as I go. Some of them can get kind of complex. So I like to make sure I know the logic of it so I don't get myself turned around. All right, great. So yeah, we overused labor. I don't know why. We have enough information now to say, hey, we can call somebody up. Direct labor quantity variance. We can call somebody up and say, hey, manager, you had a $2,000 unfavorable direct labor quantity variance. Why? We can start the process of figuring out a course of action so that we can not repeat that next time. Okay. So, yeah, let's talk about that for a second. And then I think I want to be done. Why might you have overused hours? I don't know. Why would a company use more direct labor hours than they were expecting? Any ideas? Increased demand. Okay. Well, for volume variance, that would, yeah. So if we had increased demand, we produced more than we expected, we have volume variance. But beyond that, why would we produce 1,500 finished goods units and not use 3,000 hours, but use 3,200 hours to produce that many units? Ooh, technology breaking down. We have to do more manual labor. Yeah. So we got two processes. One is more mechanized than the other, or whatever. Yeah, I like that. What else? Ever taken longer time than you thought to do something?
Yeah, this class, professor.
I get it. I am the reason. I am your quantity variance. I get it. Okay. Why do you take longer to do something than you expect? It's not like I'm not like drilling for a right answer. I can think of a few, but I want to hear your thoughts about what you think. Harder than expected. Yeah. Good reason. You don't want to do it. Okay. Yeah. New hires. Yeah. You're new at it. Like, I try it my first time. It's going to take me an hour to do this one thing that takes somebody who's good at it 2 seconds. That's pretty steep. But a much shorter time than an hour. All right, those are good. And technology we can apply here too. I was working on that essay, then my computer broke. That makes it take a lot longer. Got to get out the old typewriter no, probably can't do it. But yeah, I had to go search for a solution. It was harder than I thought. So yeah, we'll probably ask the manager something about, well, okay, why they take longer? Was there some disruption in the factory? Was there some problem with the machinery? What's the skill level of the workers that you have? Are they just, they're not doing a good job? They're newer? And if they're newer, we can start asking, well, why do we have such a young workforce in our company? Are we doing something in our company culture that's driving people out? So we keep having to hire new people to replace them, just churning through. That's gonna decrease the average skill level of our workforce and make them take longer to do things than we expect. Not because they're bad workers, they're just new. All right, a number of things we could drill down, and we'd have to get into the specific scenario and have to have a real life thing we're talking about to really know for sure the reason, but we have the right question to ask, and we'll call the right person, the person who's managing those direct laborers. Say, all right, well, tell me about your workforce. Tell me about the people on the factory floor, or we could talk about more an actual example you're going to use. Tell me about those staff auditors you have. Why'd they go over billable hours to do an audit that shouldn't take that long? So we can start to ask those kinds of questions. They aren't trained enough. They don't want to do it. They're not motivated enough. Well, what can we do to make them more motivated? How can we improve their outlook on it? All right. I think I'm done with that. I think I'm done for the day. So after spring break, we'll talk more about this, review more of this. A lot of this is going to be review for you. Maybe you've forgotten. Some of you haven't taken 206 for a number of years. We'll talk about specifically calculating quantity and price variances for direct labor and direct materials. We also get in what is not going to be reviewed for you probably is we're going to get into the journal entries, because you can set up the system so it just runs in the accounting system and spits out numbers for you. You're not just manually doing these calculations in Excel, but the system will do it automatically for you. All right, that's it. Thank you.